Another term that's used a lot in SPC is called standard deviation. It's also referred to as sigma. And sigma is used because it's frequently represented by the symbol that looks like that, and that symbol is called sigma. So if we go back to our prior sessions, and we were talking about taking measurements, and we plotted them out on a distribution curve. So we had 2.5 and all the associated numbers. And this was our diameter of a hole. And this was the frequency that those measurements came up. So if we had 10 times, we measured 2.5. Then this would be 10. And then we had other measurements that were in this range, you know, roughly 2.4 to 2.5, and so forth. Very few down that measured 2.3. And then we plotted out a bell curve that kind of averaged those out like so. Okay, and our average most common was 2.5. But we had some down almost to 2.7 here. So our amount that we were deviating was, let's say it was or 0.175. So 2.5 to almost 2.7, so a little less than 0.2. And we had the same thing on this side, only this was the negative direction. So this is how much our measurements deviated from this middle or average. So we'll take a look at another scenario here of how the measurement values can be distributed out. So you keep in mind measurement values can be in tight or they can be spread out. And if these were very in tight, our bell curve would be a little bit different. And we would see that we're about 2.6 here, so we have a 0.1 this direction, and in this direction a minus 0.1. So we're in tighter. Our values are more consistent and closer to our average. And the last scenario, kind of the opposite extreme, we'll take a look at here. It's a little bit flatter. And if we take a look at that bell curve, it looks something more like this. And we can see that from here out, we're about 0.25, let's say, and this way we'll call it the same, minus 0.25. So our normal is that 0.175. In tighter, we get 0.1 deviation. Here we're getting 0.25. Now this isn't the exact number of the standard deviation. Standard deviation is actually a different number, but this just represents the deviation of product. So in this case, our sigma may be around something like, it's going to be a smaller number. Might be something like 0.03. And here our standard deviation, or sigma, is going to be larger. That makes sense, right? And it's going to be something around, I don't know, maybe like 0.075. So the larger our standard deviation number, the more spread out our data is. Let's go back to a normal distribution curve here. And we see this symbol, that's a mu symbol. You can kind of ignore that. Instead, we use an X with 2 bars above it, X bar. And that's actually average value of all our measurements. That will be in the middle. Then we see 1 standard deviation, or 1 sigma, off to the right, 2 sigma, and 3 sigma. And then likewise, minus 1 sigma, minus 2, minus 3. And we can get the value of this by taking our X double bar plus the 1 sigma value. And likewise, the 2 sigma is calculated that way, and 3 sigma, same thing, X double bar plus 3 sigma, same thing over here, only we subtract it, minus 3 sigma. And that breaks up into categories here, and each category in the standard distribution curve, 34.1% of our measurements should fall in this region right here. Likewise, 34.1 over here, and then 13.6, 2.1 in each of these. And this describes the distribution of our data. So as we saw previously in the session, the higher the standard deviation, the more spread out our data. We still should see the data kind of fall into these patterns or categories. And we won't go into the exact formula of how to calculate sigma or standard deviation. There's a couple different methods of doing it. There's plenty of resources out there on how to do that. There's plenty of books on that, and you can pick up a book. It's not really required. It's important to understand the concept behind it, and so that as you go forward and you see standard deviation and you hear it, you know what it is. But the exact calculations are less important. But if you do want to dig into it, there's plenty of resources out there for you to research it out.